For 36 years, Voyager 1 has been flying blind, not broken, not lost. Blind by choice, by command, by a decision made in a control room on Earth, long before most of the people reading these words were born. Somewhere out past the edge of the solar wind, more than 15 billion miles from the sun, a spacecraft the size of a small car is still speaking to us, still sending back whispers of the universe it passes through, and yet it has not seen anything, not one photon captured and turned into a picture since the winter of 1990. It is the most traveled eye humanity ever built, and it closed that eye deliberately, on purpose, forever, at the exact moment it had something extraordinary left to show us. What it saw in those final moments did not just end a camera's career. It rewired the way an entire species understood its own address in the cosmos, and the story of how those images came to exist and why they were the last is stranger and more human than most people realize. To understand why the last images mattered so much, you have to go back to what Voyager 1 was built to do, and how far it had already traveled from that original purpose by the time the cameras were finally switched off. Launched in September of 1977, Voyager 1 was never designed to become humanity's most distant ambassador. It was designed to look at Jupiter and Saturn, take the sharpest pictures anyone had ever captured of the two giants, and then, if the mission held together, keep going. It exceeded every expectation almost immediately. At Jupiter, it revealed a chaotic tapestry of storms larger than entire planets, and it caught something no one predicted: an active volcano erupting on the moon. Io, plumes of sulfur rising hundreds of kilometers into space, the first time volcanic activity had ever been observed anywhere beyond Earth. At Saturn, it threaded a needle past the rings, exposing braided structures and shepherd moons that turned a flat disk of ice into something closer to a living clockwork. Every image beamed back was a record broken, a mystery solved, and a dozen new ones opened. By the early 1980s, Voyager 1 had done everything asked of it and more, and its trajectory was now carrying it up and out of the plane of the solar system, away from the remaining planets, toward the edge of everything we understood. Long before any of that, back on Earth in 1977, engineers had bolted something unusual to the outside of the spacecraft. A golden record encoded with the sounds and images of human life, greetings in dozens of languages, music from across cultures and centuries, a kind of message in a bottle thrown into a cosmic ocean with no expectation it would ever be found. At the time, it read as a symbolic gesture, a piece of optimism attached to a scientific instrument. Nobody involved could have known in that moment that the spacecraft carrying it would eventually take a picture of the very planet the record was meant to represent, one so faint and so small that it would need explaining rather than admiring, a single point of light standing in for everything, the golden record described in far greater detail. Two artifacts launched together, telling two very different versions of the same story, one loud and expansive, the other silent and almost invisible. For years after its planetary flybys ended, Voyager 1's cameras stayed dark, not from failure, but from irrelevance. There was nothing left in the spacecraft's path to photograph. It was simply traveling, sampling the thinning particles of the solar wind, measuring magnetic fields, listening. Then, in 1990, someone asked a question that had almost nothing to do with science and almost everything to do with meaning. That someone was Carl Sagan, a member of the Voyager imaging team, and by that point, one of the most recognizable scientific voices on the planet. Sagan had first proposed the idea nearly a decade earlier in 1981 and been turned down. The engineers had their reasons. Turning the cameras back toward the inner solar system meant pointing them dangerously close to the sun, risking the kind of direct exposure that could permanently damage the optics. There was no scientific case for the image. It would not resolve a single planet in useful detail. From 3.7 billion miles away, from a vantage point beyond Neptune, Earth would not even fill a single pixel. It would be a smear of light, a rounding error in a much larger frame, mostly empty black. Engineers argued it was a waste of the spacecraft's dwindling power, and a risk to instruments that still had real scientific value. Sagan argued back for years. He believed the picture was not about resolution. It was about perspective, and he kept making the case until, in 1989, under NASA Administrator Richard Truly, the request was finally approved. The maneuver itself was not simple. Commanding a spacecraft billions of miles away, with a radio signal that took over 5 hours to arrive one way, to rotate its camera platform through a precise sequence, capture a specific series of exposures, and do it all without damaging the equipment required extraordinary care. On February 14, 1990, the command finally executed. Over the course of a few hours, Voyager 1 turned its narrow-angle camera back toward the world it had left behind more than a decade earlier and began taking pictures, one after another, 60 frames in total, capturing 6 of the solar system's planets in a single extended sequence. Neptune, Uranus, Saturn, Jupiter, Venus, and, in the middle of it all, buried in a single frame scattered with sunlight, a fragile blue speck less than a pixel wide. Mercury was too close to the glare of the sun to photograph safely. Mars was washed out by scattered light bouncing inside the camera itself. Pluto, small and dark and distant even by the standards of that image, simply did not register at all. What NASA would later call the family portrait of the solar system was not and could not be complete. It was a portrait with empty chairs, and in some ways that absence made what remained more striking, not less. Here was a spacecraft looking back at the only home it had ever known, watching its family disappear one by one into darkness and distance, managing to capture only fragments of the whole. The 3 exposures that would become the most famous of all of them were taken at 04:48 Greenwich Mean Time. Blue, green, and violet filters combined to produce a single composite frame, and inside that frame, trapped in a stray beam of scattered sunlight, sat Earth. Less than a pixel across. A point of light so small and so faint that when the data finally streamed back across the solar system and arrived at the imaging team's monitors, the first person to look at it could not find it at all. Her name was Candy Hansen, a member of the Voyager imaging team, and she would later describe the moment as, in her words, kind of terrifying. She scanned the frame and saw nothing where Earth should have been. For a moment, she believed the exposure had failed, that the team had aimed the camera wrong, calculated the timing incorrectly, wasted this once-in-a-mission opportunity on an empty patch of sky. It was only after closer study that she found it, nested inside a band of diffracted light scattered by the camera's own optics, that faint, nearly imperceptible dot that would soon become one of the most reproduced photographs in the history of science. Sagan would later put words to what that image meant, in a passage that has since become one of the defining pieces of scientific writing of the 20th century. A meditation on scale, on arrogance, on the strange comfort of insignificance. Everyone who has ever lived, every war fought, every empire risen and fallen, every person who ever loved or hated or hoped, had done so on that single point of light, smaller than a grain of dust suspended in a sunbeam. The image did not need commentary to be powerful. It was powerful because of what it withheld. No continents, no oceans, no evidence from that distance that anything alive had ever existed there at all. Just a point, adrift in scattered light, indistinguishable at a glance from a smudge on the lens or a flaw in the film. And it was. Everyone involved understood almost immediately, the last time Voyager 1 would ever look at anything at all. What made the image land so hard, both for the scientists who first studied it and for the millions of people who encountered it afterward, was the contrast between effort and result. An entire mission, an entire decade of engineering argument, a spacecraft rotated with extraordinary precision across billions of miles of empty space. All of it spent to produce a photograph containing almost nothing visible at all. No detail. No color beyond a pale, washed-out blue. No feature that would mean anything to someone who did not already know what they were looking at. And yet that emptiness turned out to be the entire point. Sagan did not need Voyager 1 to resolve continents or oceans to make his case. He needed exactly what the camera delivered. A planet reduced to its true visual weight against the scale of everything else. A demonstration that required no additional argument once the picture existed. Every certainty, every conflict, every generation of human ambition, compressed into a single, nearly imperceptible pixel of reflected sunlight. The decision to shut the cameras down permanently was made almost as soon as the family portrait sequence was complete, and it came down, as so many decisions about aging spacecraft eventually do, to power. Voyager 1 runs on radioisotope thermoelectric generators, essentially nuclear batteries that convert the heat of decaying plutonium into electricity. That power supply has been shrinking slowly and predictably since the day of launch, and every watt it loses is a watt that can never be recovered. By 1990, mission planners understood that Voyager 1's future was not going to be about photography. There was nothing left to photograph. The spacecraft was leaving the realm of planets behind and entering the vast, largely empty region between the sun's influence and true interstellar space, a region where cameras would have nothing meaningful to see, and where every watt spent on the imaging system was a watt taken away from instruments capable of measuring things no camera ever could. Cosmic rays, magnetic fields, the density and temperature of plasma at the edge of the solar wind's reach. So the cameras were switched off, not gradually, not as a slow fade or a device left to run down naturally. A command was sent, and the imaging system went dark within minutes, deliberately and permanently, in a decision that traded sight for survival. What almost no one expected in 1990 is how consequential that ending would turn out to be. Voyager 1's mission did not stop. It simply changed shape entirely. Stripped of its ability to see, the spacecraft became something closer to a set of ears and fingertips reaching into the unknown, a probe defined not by what it could show us, but by what it could feel. In August of 2012, more than 22 years after its cameras closed for the last time, instruments aboard Voyager 1 detected a sudden dramatic shift in the particles surrounding it. The density of galactic cosmic rays spiked. The signature of the solar wind, the outward pressure of charged particles streaming from the sun that had surrounded the spacecraft, its entire journey dropped away almost entirely. Voyager 1 had crossed the heliopause, the boundary where the sun's influence effectively ends and the vast interstellar medium begins. It became, and remains, the only human-made object to have ever entered true interstellar space, still transmitting, still measuring, 4 decades removed from the last time it ever saw anything with its own eyes. There is something almost unbearably poetic in that sequence of events, though nobody planned it that way. The spacecraft's final act of vision was to look backward, at the tiny, fragile, complete world it was leaving forever, and only after closing its eyes for good did it cross into a region so alien, so profoundly different from anything a camera built for photographing planets could have made sense of, that its blindness almost feels less like a loss and more like a fitting transition. It said goodbye with its eyes, and then it went forward using only the senses that remained. That does not mean the years since have been silent, or that scientists have simply forgotten Voyager 1 exists while it drifts. In fact, the opposite has proven true, arguably more true than anyone in 1990 could have anticipated. The particle and field data streaming back from Voyager 1 over the past decade has repeatedly surprised the researchers studying it. The transition into interstellar space did not look the way models had predicted. Instead of a clean, uniform boundary, instruments recorded turbulence, unexpected structure, and, more recently, magnetic field readings that behaved in ways researchers are still working to fully explain. Hints that the boundary of our solar system is not a simple wall, but something closer to a shifting, textured frontier. Meanwhile, its twin, Voyager 2, which followed a different trajectory and crossed into interstellar space 6 years later, provided a second independent vantage point that helped confirm the boundary was real, and not a fluke of instrumentation, while also revealing its own unexpected quirks, differences in plasma density and magnetic orientation that neither spacecraft's builders had fully anticipated. Decades after its cameras went dark, Voyager 1 is still rewriting the textbook, just using different tools than the ones that made it famous. And now, in 2026, that story is entering what almost everyone involved acknowledges is its final chapter, not because of a sudden failure, but because of the same relentless arithmetic of dwindling power that ended the imaging system all those decades ago. The plutonium aboard Voyager 1 continues its slow, predictable decay, and the electricity available to run its remaining instruments continues to shrink by roughly 4 watts each year. NASA's mission engineers have spent the last several years performing what can only be described as a form of triage, evaluating instrument by instrument which measurements still provide the greatest scientific value for the power they consume, and shutting down the rest. Each decision is permanent. Once an instrument loses power, its heaters go with it, and in the extreme cold of deep space, without heat, the electronics inside freeze and can never realistically be restarted, no matter how much power might later become available. There is no coming back. Every shutdown is a one-way door. And unlike the loss of the cameras in 1990, which was a controlled, chosen ending at a moment of triumph, this slower unwinding carries a different kind of weight, the quiet, incremental sound of a nearly 50-year mission running out of road. Engineers describe the process almost clinically, because clinical language is the only way to survive, making the same kind of decision over and over across years. Every few months or years, the team reassesses what is left, weighing the scientific return of each surviving instrument against the electricity it demands, and choosing again and again what the spacecraft can no longer afford to keep. It is not failure in the way a mission normally fails. Nothing is broken. Nothing has malfunctioned. The spacecraft that flew past Jupiter's volcanoes and Saturn's rings and photographed a fragile blue dot from beyond Neptune is, by any engineering standard, still working exactly as designed, still obedient, still transmitting, still following commands sent across a gap of more than 22 hours one way at the speed of light. It is simply running out of the one resource that can never be replenished across billions of miles of empty space, and everyone involved in the mission knows that no amount of care or cleverness changes the arithmetic. They are not trying to save Voyager 1. They are trying to make the most of the time it has left, one measurement, 1 watt, one instrument at a time. What remains active aboard Voyager 1 today is a small handful of instruments still capable of sampling the interstellar medium directly, instruments that cannot be replaced or duplicated by any other spacecraft currently in operation or planned for the foreseeable future. Voyager 1 is, right now, the only object built by human hands actively measuring cosmic rays, magnetic fields, and the plasma environment from a position genuinely outside the influence of our own star. Every additional year the spacecraft survives, every additional watt engineers manage to squeeze out of its aging power supply, adds to a data set that cannot be recreated by any successor mission, because no successor mission currently exists that will reach interstellar space for decades, if not longer. The team monitoring it in mission control understands, more clearly than almost anyone else on the planet, what it means to watch something extraordinary approach its end in slow motion, transmitter by transmitter, instrument by instrument, watt by watt, with no dramatic final moment to mark the occasion, only the eventual point at which power falls below the threshold needed to keep even the transmitter alive. And the signal that has crossed the solar system every single day for nearly 50 years simply does not arrive. When that day comes, and engineers now speak of it not as a distant hypothetical, but as an event within a plausible, calculable window, Voyager 1 will not stop moving. It will not fall, or crash, or burn up. It will simply keep traveling, silent, carrying its golden record and its long-dead cameras and its extraordinary history outward into the galaxy, following a path it will hold for millions of years, long after every person who worked on its mission, every person watching this now, and quite possibly every trace of human civilization on Earth has come and gone. The Deep Space Network will keep listening for a while out of habit and hope, tuning its enormous dishes toward a point in the sky where a signal used to be, and then eventually it will stop listening too, because there will be nothing left to hear. And yet none of that erases what happened on February 14th, 1990, or diminishes why it still matters now, arguably more than ever. The pale blue dot was never really about resolution or data or scientific value. In the narrow sense the engineers who resisted the idea for nearly a decade had in mind, it was about the deliberate choice to spend a spacecraft's last look, its final act of vision before 4 decades of enforced blindness, not on some undiscovered moon or unexplored ring system, but on the small, improbable, singular place every one of its builders had come from. In an era where humanity is once again confronting how fragile our position in the universe actually is, watching a mission approach its literal physical end after very nearly 50 years of service, that image has only grown more resonant, not less. It is not a photograph of achievement, it is a photograph of perspective, taken by a machine that would soon lose the ability to see anything ever again, and chose, with the small amount of choice available to the humans who commanded it, to look at us first. There is a strange kind of comfort in that, if you sit with it long enough. Most endings in nature, and most endings in engineering, arrive as accidents, as breakdowns, as things going wrong faster than anyone can respond to. Voyager 1's ending, whenever it finally arrives, will be almost the opposite. It will be the product of decades of foresight, of careful rationing, of a team that understood from the very beginning that the spacecraft's power would never be replenished, and planned every subsequent decision around that single, unchangeable fact. In a sense, the mission has been ending, slowly and on purpose, since the day it launched. The cameras were simply the first thing sacrificed to that long, deliberate unwinding. And in hindsight, of everything the spacecraft ever carried, they may turn out to have been the one whose final use mattered most. Scientists were not left speechless by spectacle. There was no dramatic reveal, no shocking discovery buried in the pixels, nothing resembling the kind of sensational payoff that headlines often promise and rarely deliver. What left them speechless, what has continued to leave people speechless in the 36 years since, was the sheer, quiet weight of context. A machine built by human hands, traveling faster and farther than almost anything else ever constructed, turned back for one final look before going permanently, irreversibly blind. And in that last look, found not grandeur, not vastness, not some newly resolved wonder of the cosmos, but a fragile, nearly invisible speck of light, holding within it every person who has ever lived. That is the moment Voyager 1's eyes closed forever. And in 2026, as its remaining instruments flicker out one by one and its voice grows fainter with each passing year, that final image endures as something the spacecraft itself could never have understood, but that everyone who has ever looked at it since has felt immediately. Proof that even from 3.7 billion miles away, blind and running out of power and beyond any hope of repair, it is still possible to find exactly what matters most and to look at it one last time before the dark.